Okay, ready? Hello, world! Welcome to another episode of the Math Party. I'm your host with the most, Mr. Young. I'm here with my D&D partner. He's a dwarf. He's the commander. He's the captain, Mr. Bergstrom.
Hey guys.
So here, what we're doing today is we are converting binary to decimal. So, basic rules of binary, powers of 2, right? Powers of 2. Why is it powers of 2, Mr. Bergstrom?
Because if you have two fingers, that's how high you can count to.
That's exactly right. You have it on and off. Why do we count to 10 then? Or 9 actually, 0 to 9.
Because you have 10 fingers.
Yeah.
It's pretty basic.
Wow, that blows my mind. Blows my
Scientists.
mind. I know, right?
Scientists.
Awesome. So we're going to go with the powers of 2. We're going to refresh our memory on how the powers of 2 work. So the first one we're going to go with is the first decimal place. The first place of binary, which is this place, which is 2 to the power 0. Or in this case, 1.
So it's the ones place.
It's the ones place. Our next place over is the twos place because 2 to the power 1 is 2. 2 to the power 2 is 4. Then we keep going. Everyone should know when 4 times 2 is 8. Am I close? That's
Yeah.
pretty accurate, right? 8.
For a math teacher, you're pretty good at
Yeah,
this.
you know it. 8, 16. We're going with 32. 64, 128. Am I allowed to stop here?
I mean, you're allowed to stop there, but it goes on forever.
Yeah, it does go on forever. And most of you guys do play that video game. We keep going. 256, 512, 1024. And the last one, of course, everyone knows and loves to play, 2048. So that's what we're going to do, right? So we're going to take this number and we're going to turn it into our counting numbers. Just remember this little 2 on the bottom tells you what language we're in. So we're in binary language and we want to get to our counting numbers, which is base 10. So we're going to spread these out.
So that's not 110?
No, that is not 110.
Oh, okay.
That is not 110. This is 110. Okay? So we're going to write this down and we're going to put our place values on the top. 110. Okay? Our place values usually go from right to left. Our first positioning is the ones place. So this is a 1, 2, and then 4. Any suggestions on what we do with those numbers?
So now we're going to take them and add them together.
We're going to take them and add them together. Are we adding 4 plus 2 plus 1?
No,
No. Why not?
because there's nothing in the ones place.
There's nothing in the ones place. You're only adding the ones that have a 1 on it. So this one, we're not doing that one at all. So we're going to take this out. And we're going to add that. So my actual number here is going to be 6 in decimal, which is the power of 10.
Did I pass your class now?
Oh, totally. Flying colors.
Great.
Flying colors. All right, let's try a harder one. We're going to go with something that's even bigger. This is 6 decimal places. I know, it's a lot. We got to add more. We got to put a lot of stuff into it. All right. So, ones place. Ones place.
2,
Twos.
4,
4,
8,
8,
16,
16,
32.
32. So, we're going to add which place values? 32.
So 32.
Yeah.
No 16.
No 16, so that goes away.
We got an 8,
We got an 8.
4,
4, that's correct.
2,
2.
no 2.
No 2.
And a 1.
And 1. So we're going to add this up. So we go 32 plus 8 plus 4 plus 1. That in total gives me a grand spanking new 45.
Hold on, let me just check his math, guys.
Yeah, he's got to check it. You got to make sure.
Yeah,
You know,
that looks good.
sometimes you know, you could be a math teacher, but sometimes you need a calculator or Bergie. Bergstrom, Mr. Bergstrom is the human calculator sometimes. All right, so we're gonna get into something even harder. We have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a total of 9 numbers here. This is gonna be a doozy. I'm gonna need a calculator. I don't think Bergstrom's gonna need a calculator. But we're gonna.
When you're good, you're good.
Yeah, that's right. All right, I'm gonna put the place values here. Bergie's gonna check my answers. We have the ones place.
Wait, hold on.
Yes.
Yeah, that seems right.
Okay. Ones place, twos place, 4s, 8s, 16, 32, 64, 128. And like we said on the first one, you can keep going. Just keep multiplying by 2. So the next one's going to be 256. So the more numbers you have, the more numbers you're going to have to multiply by 2. So now from what Bergie said, we're only going to add the ones that have ones on it. So the 256 works, 128 works, 64 doesn't, 32 doesn't, 16 nope, 8 yes, 4 yes, 2 no, and 1 yes. So far so good, Bergie?
So far so good.
All right, Mr. Bergstrom, he is the man. He always double checks what I do. Sometimes, we all need that one person to help us out.
Hey man, everybody makes mistakes. It's okay.
That's right. Okay, so here's my numbers. If I add these up, 256 plus 128 plus 8 plus 4 plus 1, I believe that gives us 397.
Wait a second, you just used a calculator. You're supposed to be able to do that in your head.
Minor detail. They can't see that. But there it is, 397 base 10. Remember, this little small number is your base, what language you're reading off of. All right, I think that's about it. I think we got three questions solved. I think we're good. I think they should be well prepared.
Good luck, guys.
All right.
You're going to need it.
All right. Until next time, have a good one.